Okay, question number 23. A light of wavelength 5.8 into minus 7 meters lambda is given to you is normally incident on a diffraction grating that has around 1, 2, 3, 4 into 10 power 5 lines per meter. Okay, n is given. How many maxima can be observed with this diffraction grating? You know, if this value of n is given, you can determine the value of b. What is b? The distance between one slit and the other slit. Okay, in a diffraction grating, okay, which is around 3.5 inches, you have several lines which are being etched by a diamond. This is what you get over here. The distance between one line and the other line is nothing but your PO. So you need to get this value. But what is given here is this value. Okay, how many number of lines are there? Okay, it says this much number of lines per meter are present. How do I get this? So the simple formula, I can say that B is equal to 1 by n, which should now be equal to 1 by 1, 2, 3, 4, 5. Which should now be equal to 0.25 multiplied by 10 to the power of 1, 2, 3, 4, 5, 10 power minus 5. So this is what is the number of the distance between one line and the other line. What about a slit? Now we know if you want to have a constructive diffraction, so there is an equation which says b sine theta is equal to n lambda. Now if I consider n equal to 1 over here, I can now write b sine theta is equal to lambda. Now what is he asking? How many maxima can be observed in diffraction grating? The maximum, see what happens is, if you keep the diffraction grating like this, you put the source over here, a beam of light comes over here, and then it gets diffracted like this. Okay, and how do you measure the theta angle? You measure this as your theta angle. What is your maximum value of theta? So this is your screen, right? Your screen. So you can have theta values like this. You can go like this over here. Let me assume this is your maximum value. This is your maximum value. 89 degrees could be the maximum, but I'll consider this 90. So therefore, 90 degrees is your value of theta. The max value of theta could be 90. So I can put theta equal to 90 here, and thus I can now write b. So there should be an n here. I missed this n here. N here should now be equal to b should be equal to n lambda, or n should be equal to b by lambda. Now let us calculate the value of the n value. What's the value of b here? B is 0.25 into 10 to the power of minus 5 divided by what's the value of lambda? 5.8 into 10 to the power of minus 7. When I do this calculation, so that you get a clarity on what we're doing, 0.25 divided by 5.8, I get the answer 0.043. 0.0043 into this minus 5 plus 7 becomes 2 over here. So when I multiply this by 10 square, I get this as 4.3, and I'll just take 4 over. Why 4? Because we're talking about the orders of diffraction. An order of diffraction cannot be a fraction or a decimal. It should only be some value 4 over here, integer multiple. Therefore, now what is this 4? Which means that you can have 4 orders of diffraction pattern above the central point, and 4 orders of the diffraction pattern below the central point, and you will have one central fringe over here. Which means what? You can have 4 here, 4 orders here, 4 maxima you can observe here. You can have one central maxima here. You can have 4 central maxima here also. So totally how many central maxima? You can find 4 plus 1 plus 1, totally it is 9 central maxima. Okay, 99% of the students who attempt this problem to get an answer 4, and immediately they are saying, sir, I have got the answer, I'll mark this. Okay, it is incorrect.